All right, 11 and 12 are both going to require a bit of calculator work because no matter how hard you try, start with Pythagorean theorem here, the 6 squared and the negative 4 squared. No matter how hard you try, you are not going to find negative 4, 6 on your unit circle. You might be able to find a really weird unit circle out there. You know, maybe you still have a grandfather with a slide rule. Who knows? I'm going to use a calculator because it's 2019. So I'm starting with the left coordinate here. We don't need a calculator for that. 6 squared is 36. Negative 4 squared will be a 16. So putting those together gives me a root 54. 54 we can break up. 54 is the same thing as 4 times 13. And the square root of 4 is just 2. So no worries on the left coordinate. It's the right coordinate that's kind of So tan inverse of negative 4 6. So my calculator right now, I believe, is in degrees. Yes, I'm currently in degrees. I'm going to go ahead and just stay in degrees. You could do the same thing in radians. The instructions don't really say one way or the other. So I'm going to go ahead and just stick in degrees here. So what I want is tan inverse of negative 4 over 6. You can reduce that to negative 2/3 if the fraction there is bothering you. Now keep in mind, because of the domain and range issues here, what tan inverse is going to give you is negative 33.96. Again, tan inverse is always going to give you something between negative 90 and positive 90. So it's giving us this negative 33-degree angle here. I don't really want that negative angle. If you gave me that one, I would give you full credit. However, I would rather have a positive angle. So I'm going to find a coterminal angle by adding 360 degrees, and that's going to give us 326.31. Again, skipping a whole lot of work there. Thanks, calculator. It is important to still kind of double check, like, did I get what I wanted here? 6 comma negative 4, that was a quadrant 4 angle because of that negative sign there for the y coordinate. So it is important to double check that this is also a quadrant 4 angle. 326 degrees is definitely between 270 and 360. One of the main reasons I stuck with degrees instead of radians is that it's much easier to visualize 326 degrees than whatever the heck that is in radians. So again, this is also a quadrant 4 coordinate pair, so that does check out. Jumping over to number 12 here, it's going to be very similar. We're just talking about calculator work. So I have the square root of negative 1 squared plus negative 7 squared. And then I need to take tan inverse of y over x. Good times. Starting with this radical, negative 1 squared is positive 1, negative 7, that 2 is on the wrong side. And the negative 7 squared will be 49. So putting those together, we get root 50. Again, we can break that radical up into 25, 2. Square root of 25 is just 5. So that reduces to 5 root 2. Looking over at that tangent inverse, again, you can try as hard as you want. You're not going to find 7 on your unit circle. So tan inverse of 7. Let's go ahead and clear all of this out. All right. So then we want tan. Well, that's interesting. So tan inverse, again, negative 7 over negative 1. That just reduces to 7. So inverse tangent of 7 is going to give me the angle 81.87 degrees. Now we want to be careful here. Jumping back to our original point, 12 there, that is a quadrant 3 angle. That's a quadrant 3 angle because both of these are negative. So we want to make sure that we're getting back a quadrant 3 90-degree angle. You think about 81 degrees there. Oh, apparently I can't draw on this. So if you think about 81 degrees is a quadrant 1 angle. So if I want to keep things consistent, I can use that 81 degrees with 87. But then my R value needs to be negative because I started with a quadrant 3, and this angle is actually a quadrant 1. So this is a totally acceptable, just fine answer. Keep in mind your calculator is limited here. It's only going to give you something between -90 and +90. If we want something in standard form though, in other words, no negative numbers, we can just add 180 degrees, and that will give me the angle in standard form, 261.87. And then I don't have to worry about those negative R values. 261. So again, this is what I recommend. If you only have to worry about positive numbers, it's just less chance to make a mistake there. But this is also a totally complete and correct answer. Either one of those would be acceptable. So at this point, we have taken a look at 6 examples going from polar to rectangular and 6 examples going from rectangular to polar. Yeah, if you have any questions, comments, concerns, or feelings, definitely make sure you get those addressed, and see you soon.